we have to start with the new theorem. And the name of the new theorem is Green's theorem today. We shall discuss about the verification of Green's theorem with the help of an example. So let us start with that. Today's lecture will include Green's theorem, and the statement is if m of xy and n of xy are continuous functions of x and y having first order partial derivatives. Partial derivatives are del m by del y and del n by del x. These derivatives we require. These are the first order partial derivatives of m and n in a region R of xy plane bounded by a closed curve C. Then integral along C m dx. M is the function, it is defined here. M dx plus n dy is equal to double integral over R, that is del n by del x minus del m by del y into dx dy. So this is we need to verify. This is a single integral on the left hand side and this is the double integral on the right hand side of equal. So we must verify both sides equal for the verification of Green's theorem. So this is the statement of Green's theorem, and C is transverse in the counterclockwise direction. Counterclockwise means anti-clockwise direction. So C should also be taken always in the anti-clockwise direction. Now, let us take the example. The example is verify Green's theorem for the function. The statement is straightaway not a function, it is the integral given to us. Verify Green's theorem in the plane over C. This is 2xy minus x square into dx plus x square y square into dy, where C is the boundary of the region enclosed by y equal to x square and x equal to y square. So these are the two parabolas actually which we have been given. So the region is bounded by these two parabolas. This is upward parabola and this is upward and this is a right parabola. So if we compare this left hand side with this, the coefficient of dx is m. So the coefficient of dx is m. So this is your value of capital M. It is a function of x and y. And similarly, this is your capital N. So m and n are there. And we should be able to evaluate the partial derivative with respect to y, that is 2x, and derivative with respect to x, that is also 2x. And let us plot these parabolas because we require a region for the integration. This is xy plane, this is x-axis, and this is y-axis. This is the upward parabola. X square is equal to y, and this is your right-handed parabola, y square equal to x. So this is the region bounded by these two parabolas. So name this point as P, and this is the origin point O. Let us find out the point of intersection. Use the value of x here. And what is the value of x? Y square. So you can substitute y square in first parabola, that is equal to y. Y can be taken common. It will be like this. So y is either 0 and 1. If we use 0 here, x come out to be 0. If we use 1 here, x come out to be 1. So the points are clear. This is origin point and this point P is 1, 1. And C is the curve. It starts from this point of intersection to this side. So you will move along OP, then come back to O. So we always take anti-clockwise direction. And this O to P and P to A is the curve C. This is the total curve C, and clearly it is a closed region. Now we have to find out the left-hand side now. The left-hand side, this one of the Green's theorem involves the two curves. This is a C1 and this is C2. So it is comprising of a C1, and it is clear that is 2xy minus y square x square plus dx plus x square plus y square dy. We are going to split the left hand side into two integrals, over C1 and over C2. So this is 2xy minus x square into dx plus x square plus y square into dy. So this is your left hand side. First we shall evaluate left hand side, then we shall find out the value of right hand side, and we will see that both sides are same. Now over C1, what is your curve C1? You just see O to P is C1, and this is the curve y equal to x square. So if y equal to x square, dy equal to 2x dx. This will be the derivative over C1. And similarly over C2, your curve C2 is from P to O. Just see the figure. From P to O, this is C2. And what is this? This is x equal to y square parabola. Then dx should be equal to 2y dy. Now let us find over C1, this one. You will substitute the value of y equal to x square. So put y equal to x square here, you will get 2x cube minus x square dx. And here, that will be x square plus, put y equal to x square, you will get x4, and this is dx. And clearly this is integration with respect to x. So you must require the limits along O to P. From O to P, x varies from 0 to 1. So your limit is 0 to 1. Now, clearly this x square will be cancelled with this. So it is negative x square, it is positive x square. So next we have integration 2x4 over 4, x5 over 5. The limits are 0 to 1. This is 2. So it is 1 by 2 plus 1 by 5. This is 7 by 10. So this is over C1. We will have value 7 by 10. So let us find out over C2. Over C2, you will substitute x equal to y square. So 2, that will be y into y square will be y cube. Wait a minute. You just substitute the value of dy here. This is a little mistake. This is rectified. We need to substitute the value of y here. So I think the value will change. So let us change accordingly, because we have to substitute the value of y, dy, sorry. So this is the dy. Dy is equal to 2x dx here. Ultimately, it cannot be cancelled now. So what we have 0 to 1, 2x cube minus x square plus this one will be 2x cube plus 2x5 and into dx. Now you can integrate 2x cube, 4x cube, that will be 4x4 over 4 minus x cube over 3 plus 2x6 over 6 within the limits 0 to 1. So this is 1 minus 1 by 3 plus 1 by 3. Ultimately, it is 1. So this come out to be 1 because this will be cancelled. Over C1, the value of the integral is 1. This is curve C1, O to P. Now come back from P to O, this is C2, and put the value of x equal to y squared. So this will become 2y cube minus y4, and the value of dx will be 2y dy plus x square mean y4 plus y square into dy. And along over C2 coming from P to O, and you have to integrate with respect to y. So the limits from P to O of y are 1 to 0. So the lower limit is 1, upper limit is 0. So let us simplify it. That is 2 2s are 4y4. This is 2y5 plus y4 plus y square into dy. Let us 4y4 y4. 5y4, this is 5y5 over 5, 2y6 over 6 plus y cube over 3. This is lower limit is 1, upper limit is 0. So let us substitute the limit now. This come out to be 1 minus 1 by 3, and sorry, you have to substitute upper limit first. For upper limit 0, all the values will be 0, and for lower limit 1, this is 1 minus 1 by 3 plus 1 by 3. So this is cancelled. Negative 1 is the value. This was your positive 1 over C1, and over C2 we have negative 1. And when you will find out the sum total, this come out to be 1 plus minus 1. So the left hand side come out to be 0. Now, let us verify whether the right hand side also come out to be 0 or not. So right hand side is double integral over R, that is the del m by del x minus del m by del y into dx dy. And we know that both have values 2x, 2x. So 2x minus ultimately the integral come out to be 0. Thus the left hand side is equal to the right hand side. It means Green's theorem is verified because both the sides are same. So this is the procedure to verify Green's theorem. The question may also come like this, that find out the value by using Green's theorem. Suppose they say that find out the value of this integral by Green's theorem, then you will use Green's theorem, and by Green's theorem this is equal to double integral. Then you will find the right hand side only, and you will get the value from right hand side. Next we have the question related to Green's theorem. And the question is verify. This question is not of verification. This is evaluate actually. Evaluate integral along C. This is e power minus x into sin y dx plus e power minus x into cos y dy. This is we have to evaluate, where C is the rectangle with the vertices. This is the rectangle given to x axis, y axis, and the coordinates are 0, 0. This is pi 0. This is pi and pi by 2. This is 0 and pi by 2. So these are the coordinates of the rectangle OABC moving in anti-clockwise direction. So by Green's theorem, this should be equal to double integral over R del m by del x minus del m by del y into dx dy. The same question, this one, may also come for the verification. So in that case, you have to evaluate left hand side and right hand side both. If you want to evaluate left hand side, the total curve C has already been taken, so we change this name to P. So the total curve C include 4 straight lines: OA, AB, BP plus PO. So you will evaluate along all these 4 straight lines and sum up all the integrals. You will be able to get the value of left hand side. But this is a different question. This is to evaluate. So you will evaluate the right hand side only. Del n by, this is clearly m, and this is clearly n. And del n by del x is minus e power minus x into cos of y. This is by integration. And del n by del y, e power minus x into cos of y dx dy. So ultimately minus 2 e power minus x cos y dx dy. This is the question. Now you have to find out the limits. In the xy plane, the limit of x varies from left to right. This is for x limit along the horizontal axis. We shall draw this stripe. Similarly, we shall draw a vertical stripe for the limits of y. This one. And now the limits of x. The limits of x comes from left to right. This is a rectangle, and from this point to this point, like this. If we draw the semicircle, then you know that we have limits of x from 0 to pi. But for the limits of y, for the vertical stripe is at 90 degrees, so y varies from 0 to pi by 2. Lower limit will always be 0 because we are in positive octane. So 0 to pi and 0 to pi by 2 are the limits of x and y. E power minus x over minus 1, 0 to pi. Integration of cos y is sin y, 0 to pi by 2. So put the value here. Put the value of the limits. This comes out to be e power minus pi minus 1. And this is 1 minus 0. So this is your required value of the integral. 2 e power minus pi minus 1. So this is your required answer. So this is the procedure to find out the solution of a question by the help of Green's theorem. One more question may be done by the help of Green's theorem. The question is, apply Green's theorem to prove that the area enclosed by a plane curve is. This is the area we need to prove for the curve this x dy minus y dx. Hence find the area of an ellipse whose semi-major axis is x small a and semi-minor axis is small b. So this is the shape of the ellipse along the x-axis and this is along the y-axis. This is semi-major axis AA. This is semi-minor axis BB, respectively. We know that what we should have. If we compare it with left-hand side, m come out to be minus y and n come out to be x. So by the help of Green's theorem, this should be equal to double integral over r del n by del x minus del m by del y into dx dy. So this is we have to evaluate over r del n by del x. Derivative of n with respect to x is 1 minus del n by del y, that come out to be minus 1. So ultimately it comes out to be 2. So you can take 2 common dx dy over the region R. What is the region R? R is enclosed by the curve C. The curve C is the ellipse. So this is the region enclosed by the curve C. And we know that this is the equation of ellipse x square over a square plus y square over b square. And for this we can substitute put x equal to a cos theta, y equal to b sin theta. And you can get the values. And on the left hand side, what we have, the left hand side, and it is clear, this is the area of a plane. You can write down. And what is the plane? Plane curve actually. Plane curve is ellipse. So on the left hand side, the required area, if we want to get, you can name it as equation number 1. So equation number 1, area is equal to 1 by 2 double integral. This is single integral actually. This is x dy minus y dx. We shall use this one now for finding out the area. Why I have written this is equal to area of the plane curve? Because this is the formula for area. The formula for area is double integral dx dy. But it is we have taken double because we are here we are counting the area above major axis. So if we are double, we are getting the double value, then the area of a complete ellipse is there. So now substitute the value of the x. What is x? That is a cos of theta. What is the dy? Dy is b cos of theta d theta. And y is b sin theta. Dx is minus a sin theta d theta. The value have been substituted, and it is 1 by 2 integral ab is common cos square theta plus sin square theta into d theta. So cos square theta plus sin square theta is 1. And what are the limits of theta? Theta varies from 0 to 2 pi because it is the question of ellipse. So 1 by 2 AB integration of d theta is the theta. So after substituting the limits, that will be this. So this is your area of ellipse. So by this way, you will be able to find out area of ellipse by the help of Green's theorem. So this is the question of Green's theorem. And next, we shall discuss about the Stokes theorem. This is also very important. And we shall continue in the next class. हाँ जी स्क्रीन शेयर नहीं हो रही थी कहाँ तक अटेंड किया
सर लास्ट वाले क्वेश्चन पे बंद हो गई थी
आज एलिप्स वाला नहीं थी
हाँ जी
ऐसा तक हो गया थी ऐसा तक
हाँ जी सर हो गया
सर तक हो गया
ये वाला क्वेश्चन हो गया थी
हाँ जी सर ये हो गया था
एलिप्स वाला रह गया थी एलिप्स वाला क्वेश्चन ਸੀਗਾ ਕਿ ਅਸੀਂ ਇਸ ਵੈਲਿਊ ਨੂੰ ਯੂਜ਼ ਕਰਕੇ this is your left hand side by using this we have to find out the area of ellipse ये ellipse की इक्वेशन आपने +2 क्लास में पढ़ी होगी ये वाली जो ellipse होती है इसमें सेमी मेजर एक्सिस A है सेमी माइनर एक्सिस B है और ये इसकी इक्वेशन है दिस वन ये इक्वेशन ऑफ एलिप्स है। इसमें अगर हम इसको कंपेयर करें लेफ्ट हैंड साइड तो m आ गया -y, n आ गया x। बाय ग्रीन थ्योरम दिस इज इक्वल टू डबल इंटीग्रल del n by del x minus del m by del y dx dy। डेरिवेटिव फाइंड किया, n का डेरिवेटिव x से 1 माइनस m का डेरिवेटिव y से -1, तो ये बन गया 1 + 1 2 डबल dx dy। ये जो पूरा है वैल्यू, इसको हम बोलते हैं एरिया ऑफ प्लेन कर्व। यहाँ प्लेन कर्व कौन है? एलिप्स। तो एरिया ऑफ एलिप्स इज दिस। इसको आपने नंबर 1 दिया और ये किसके इक्वल आ रहा है? दिस इज इक्वल टू दिस वाज योर स्टार्टिंग पॉइंट। सो यही तो हमने फाइंड करना था। सो द एरिया इज इक्वल टू 1/2। ये जो स्टार्टिंग वैल्यू है वो हमने ले ली और एलिप्स में हम लोग पोलर कोऑर्डिनेट्स पुट कर देते हैं, x इक्वल टू a cos थीटा, y इक्वल टू b sin थीटा। पुट हियर a cos थीटा, dy का डेरिवेटिव ऑफ दिस इज b cos थीटा d थीटा, y की वैल्यू b sin थीटा, dx मतलब इसका डेरिवेटिव माइनस a sin थीटा d थीटा। अब इसको सम अप किया, a b कॉमन, cos स्क्वायर, माइनस प्लस, साइन और साइन स्क्वायर, इसकी वैल्यू 1 होती है। और हम लोग क्योंकि एलिप्स में है, एलिप्स क्या है? एलिप्स इज मूविंग लाइक दिस सेमी सर्कल एंड देन वी हैव अ कंप्लीट सर्कल। सो द लिमिट्स आर 0 to 2 पाई, कंप्लीट रेवोल्यूशन इज देयर। तो 0 to 360 लिमिट्स आ गई और अपर लिमिट 2 पाई माइनस 0, क्योंकि डी थीटा का इंटीग्रेशन क्या होगा? थीटा। तो एरिया कम आउट टू बी पाई ए बी। यहां तक मैंने करा था। ओके, अब हम इसके बाद जो स्टोक्स थ्योरम करेंगे वो कल के लेक्चर में करेंगे। तो वो स्टोक्स थ्योरम से भी ऐसे ही 2 क्वेश्चन आएंगे, एक होएगा वेरिफिकेशन का और एक होएगा उसको यूज करके एक साइड निकालना, चाहे लेफ्ट हैंड साइड निकालना चाहे राइट हैंड साइड निकालना। देखिए ये जो सेकंड क्वेश्चन हमने किया था, ये वाला दिस वन, इसको देखिए जरा ध्यान से। ये वाला, ये क्वेश्चन में ये फाइंड करना था, फाइंड दिस बाय ग्रीन्स थ्योरम, दिस इज दे हैव गिवन टू अस। तो हमने ग्रीन्स थ्योरम को यूज करके ये कर दिया और वैल्यू निकाल दी। ये बात का खास कर, और मोस्टली केसेस में ये लेफ्ट हैंड साइड ही निकालने को आता है, क्योंकि राइट हैंड साइड में कभी भी दिया जाएगा फाइंड राइट हैंड साइड, दे ऑलवेज से फाइंड लेफ्ट हैंड साइड। तो लेफ्ट हैंड साइड इक्वल टू राइट हैंड साइड, दिस इज कॉल्ड रीजन इंटीग्रल। इसको रीजन इंटीग्रल ओवर आर कहते हैं। रीजन क्या है? एरिया बाउंडेड बाय दिस रेक्टेंगल। रेक्टेंगल में 4 साइड्स हैं, 4 साइड्स हैं, सो एरिया बाउंडेड बाय दीज 4 लाइंस। ओके, बट यू मस्ट नो हाउ टू वेरीफाई ग्रीन्स थ्योरम। उसके लिए ये राइट हैंड साइड तो कर दिया, लेफ्ट हैंड साइड आपके लिए होम टास्क है। इसको ओवर सी फाइंड आउट करना है। ओवर सी मतलब 4 कर्व्स हैं, ओ ए बी पी एंड देन पी ओ। तो इन चारों के अराउंड फाइंड करिए और सम करके देखिए, आपके पास यही वैल्यू आएगी जो अभी राइट हैंड साइड की आई है, दिस वन, यू विल गेट द सेम वैल्यू। तो थ्योरम वेरीफाई हो जाए। चलिए, वी शैल कंटिन्यू इन नेक्स्ट क्लास टुमारो एट 3। थैंक यू वेरी मच।